Hello everyone. Our group is group number 6, and my name is Fu Fan, and this is and our project is about stock market prediction. As far as we know, stock market is really important, and as a stock buyer, you want to know the movement of stock so that you can know the right time to buy and to sell stock to make profits. So that stock market prediction is really important. But stock prices are really highly unpredictable. They do not follow any consistent pattern. But that doesn't mean that we cannot try. So there has been several solutions that try to solve this problem, like using linear regression, k-neighbor reinforcement, learning reinforcement, deep reinforcement learnings, and for our team, we believe that we should use a model that can take the sequence of data into the consideration, because the price of stock tomorrow will be related to the stock price of the previous day. So we believe that we should use a model that can take the sequence of data into our consideration. And long short-term memory is really a powerful time series model, because it can not only take the previous historical data into consideration, but it also can really retain in a really long-term memory that the original recurrent neural network cannot do it. So here to work on our data set, we built the data set from BlackRock Global Energy and Resources. The data set includes the open day, high, low, close, and the volume. And for our model specifically, we choose the window size of 10, and our goal is that based on this window of 10, we will predict the stock price on the data following that window.
Okay, so as my colleague said, we used LSTM model. Actually applied two models. Okay, this is our first model. This is our input data, like open, close, high, volume. Then we normalize this data by window, okay, of size 10, because our price is highly changes. So if we normalize all the data, it could distort our features. So here the performance for daily prediction is considered high accuracy. The root mean square is very low, and we used a number of neurons, 32, epochs 5, and our activation function is linear because it is a regression problem. This graph represents 10 days of prediction, but day by day prediction. And this is data normalized.
So day by day prediction means the 2 days you predict the
1 day ahead based on the actual data.
Okay, so for example, in here the 2 means what?
The day 2.
Day 2. Day 2?
Day 2,
What's the difference day 1 and day 2?
Okay, we have our data input is window 10. Okay, that means we take 10 days.
Last 10 days.
Last 10 days, okay. And we predict, we move day by day. So our prediction based on the last 10 days.
Last 10 days.
Last actual 10 days.
So actually, before this, there are a lot of days.
Okay. Then you predict 2 days after, 3 days after, 4 days after, up to 10 days after.
Yeah, but to answer this question, here we predict the 10 days ahead. It's like this is our final day, and we want 10 days ahead. So here it's prediction based on the previous prediction.
What about the previous slide? So for example, in this from the
For example, here we predict the day 4. We suppose that we already know the day before the day 4, 10 days before the day 4. But in the next line, we predict the whole 10 days.
What about the Y value? What does that mean, the Y value?
Okay, because we normalized our data window by window, so our prediction is also normalized. So this
Normalized.
is,
It's okay. So normalize the stock value.
Yeah.
Yeah.
So
Okay.
we normalized the
So
output.
if the blue and the orange one is close, that means the prediction is good.
Yeah, it's better. So here, this is. Okay, this is our first.
So
model.
the next 2 days, up to 2 days is pretty much good, right?
Yeah, and this is our last day. Okay.
But suddenly 10 days after it's getting close again.
Yeah, but here, because after trying the model many times, for example, here we have very close.
Yes.
Yeah, this is day by day, but here we used many structure for the neural network. Here we use 320 numbers with high number of epochs, so it gave us better result here. But for weekly prediction, 2-week prediction, it's like
This is a
taking,
weekly prediction.
but the same model. So it is better, but we understand that maybe because of we increase the number of neurons dramatically, so it's like, and the epochs 100, it's like there's overfitting, so it takes the directional accuracy in the wrong direction.
I think you'd better clarify what is the dependent variable, what is the independent variable. Number of days to your prediction and the number of neuron. So you need to clarify when you design the experiment. So we are going to evaluate our model based on the different the number of neuron, or the different number of days, the prediction, and so on. And even the epoch, how much time. So then you can, if that is your setup, then during the evaluation, you can just follow your setup when you evaluate. Based on the different number of days, based on different number of neurons, then the model shows this kind of result. At the time, this is a classical way to show the time series data to evaluate if they are close together, it's the best one. If far, it's not good. Also, there might be the way to calculate the mean squared error, something like that, from the actual value and your predicted value, and overall, what is the accuracy, and show that at that time, then people can believe that you can say in your conclusion, in this case, my model show the best result, something like that.
But yes, exactly. This is our first model. And actually, we tried different type of structure of neural network, but we didn't feel that we can have better accuracy. So we tried to come to a different model. Okay. Here, our different model is that we are going to start with our input data, then normalize this input data, and here our contribution for feature extracting, then standardize LSTM. Here, our feature extracting, that our inspiration comes from two things. Yeah, we know LSTM learning the features, but like deep neural network, it can learn features, but but we use convolutional neural network because convolutional neural network can learn specific features that DNN can't learn. This is our first inspiration. The second, for neural intrusion detection system, that there is a Kitsune paper that they use feature extraction. This feature extraction can learn a specific feature that we can use for our neural network. So here we found that we can find 42 feature extraction from our data. We have only 4 features. So the first feature, for example, like mean. Our problem that when we think about the time series problem, that the data is volatile, high complex, nonlinear. So, and there is a lot of noise. So if we take the mean for as an example, we can consider it like low pass filter, that we can remove the noise about this. Then we can take like variance, covariance between day 1 and day 2, and then take the covariance between close and high. And we believe this kind of feature could have better representation for our model, because stock market is like random, that there is no specific pattern. So here we consider only 5 features as a start, like mean between the first day, sum, variance, and covariance. We have better results like daily prediction, that for the day number 10, it is very, very close. And we use only 32 neurons with 5 epochs. Okay? We didn't use huge structure. For weekly prediction, here like our direction accuracy is a little bit better than the traditional model. This is with 5 features, so we believe if we can come up with more features, actually, like yesterday, we can come up with 48 features extracted. It's like the concept of convolutional neural network and the concept of intrusion detection system, that if we can come up with more features that can have unique representation of our graph, this could have better input for our LSTM. This is our conclusion, and we hope that it comes through, and this is a part of... here we use another thing like the direction of prediction, and this is maybe better for weekly prediction, because when we tried our model for like larger windows, like 50 days, we observed that it takes like direction. So it is more important for us to know if we are going, there is increase, or if it's negative, or there is decrease.
Okay. My suggestion is you update a lot, right? After you submit the last night, right? So it's, I cannot see some of the result from your writing up. So why don't you update to your writing up based on the presentation? Right? At least you need to include this one. But at that time, you do better have the direction of a presentation. Okay, what is your setup and what is the problem, whether you are going to find the optimal of the what, and then when you evaluate and when you present your evaluation, you can show that mine is stable, mine is affected by this one, this is the best case, and so on. Accordingly, you can change it, you can revise the poster. Okay? Thank you.